Hello, in this video we are going to look at Markov chains, and this is for learning intention number 49. Alright, we did this last year and it's the exact same thing, and they're actually phasing it off the methods course. So next year, I believe for the new study design, it won't be on the methods course. However, it could be on the exam this year. You never know. They could sneak it in there for a last time. So let's look at an example, and you should have your notes from last year anyway if you get stuck with this, but let's refresh. So the Loshiovo family take a holiday every summer. So they choose between a resort in Cairns, so they can either go to Cairns, and visiting relatives in Tassie. So here's Tassie. So they can either go to Cairns or to Tassie. If they fly to Cairns one year, the probability of returning to Cairns the next year is 0.4. So the way I like to write this is I like to start at Cairns and we're going right back to Cairns. So that's 0.4 there. That's the probability of them returning to Cairns the next year. They decide to visit their relatives one summer in Tassie. There is only a 0.3 chance of a repeat visit the following year. So that's 0.3 that they'll visit their relatives again the next year after visiting them the first year. Maybe they learned from that year visiting their relatives. Alright, so we need to fill in some things. If there's a 0.4 chance they go to Cairns, then there's a 0.6 chance here they go from Cairns to Tassie. The same thing here, if there's a 0.3 chance they go back to Tassie again, then there's a 0.7 chance they go to Cairns. I really like this diagram. This is what we call a state space representation of the problem. It's actually from engineering. They don't seem to do it in the textbook, but I really like this diagram. In a particular year, the Loshiovos visited their relatives in Tassie. What is the probability that they were holidaying in Cairns 2 years later? Okay, the first thing to do is set up your transition matrix. So this is a 2 by 2 matrix that encodes the information here. So let's set up that matrix. So it's 2 by 2, and I'm going to put some hints up here. Let's have Cairns here, and I'm going to do C0. So C0 means like the initial condition, and I'm going to put Tassie 0. Oh, that's going to be confusing because this is a transition matrix. Alright, let's change this to R here. Let's change it to R. It's going to make our lives a bit easier. Let's call it relatives instead of Tassie. So this is going to be relatives now. Okay. So and this is relatives and R1. So I like to, you can put those there to help you. What all this is saying is, this is going to Cairns one year, this is going to Cairns the next year, this is going to see the relatives one year, this is going to see the relatives the next year. So what's the probability they go to Cairns from one year to the next? Well, from one year to the next, that's 0.4. Going to see the relatives from one year to the next is 0.3. Okay, going from the relatives to Cairns is 0.7, and going from Cairns to the relatives is 0.6. Now you should remember that the columns have to add to 1. So that's a quick sanity check for your transition matrix. The columns should add to 1. 0.4 plus 0.6 gives us 1. 0.7 plus 0.3 gives us 1. If the rows add to 1 instead, you've probably just put the information in incorrectly. So go back and put it in correctly. Remember, this is the initial this is starting, this is where we end up. So we're going from here to here. So we're going from visiting relatives to visiting relatives again. So make sure you get that right. Apart from that, you can pretty much set up your equation. So S naught, which is the initial condition, sits kind of like this. So this top one's going to Cairns, this bottom one's visiting Norellos. So you can see in particular year the family visited their relatives in Tasmania. So the probability that they visited their relatives in Tasmania that year is 1, because they visited their relatives in Tasmania. We've been told that. So the probability that they visited is 1, whereas the probability they went to Cairns is 0. So now we've got all the information to work out this problem. What is the probability that they were holidaying in Cairns 2 years later? Well, let's look at 1 year later first. So S sub 1 is 1 year later, and that's going to be our transition matrix times the initial condition. So we take our transition matrix, and you'll notice this is a no calculator problem, and we times it by the initial condition. Okay, 0.4 times 0 is 0, 0.7 times 1 is 1, 0.6 times 0 is 0, 0.3 times 1 is 0.3. There we are, there's our S1. Great, but we want 2 years later. So we want S2, which is the transition matrix times S1. So that's 0.4, 0.7, 0.6, 0.3 times S1, 0.7, 0.3, alrighty. So we have 0.4 times 0.7, which is 0.28, 0.7 times 0.3, which is plus 0.21, 0.6 times 0.7 is 0.42, plus 0.09. Okay, so we get 0.49 and 0.51. Okay, there's our state 2. So another equation you could use to work this out is that S2 is T squared S naught. You can see where that comes from, right? Because if, I'll just do the working here, if S2 equals T times S1, well, we know that S1, we can sub this in over here, is T times S naught. So that becomes T squared S naught. Or in general, we say Sn is T to the power of n S naught. So that's an important equation to remember. Anyway, let's answer our question. So it's saying, what is the probability that they were holidaying in Cairns 2 years later? Well, this entry up here is the probability that they're holidaying in Cairns. So it's going to be this probability up here. So we can say the probability is 0.49. There we are, there's our answer. We've extracted it out of this matrix. But you know what we're going to do now? We're going to check it on our CAS. We love CAS. We love checking answers on CAS, making sure we know how to do things. Okay, let's use this formula to check it. Let's use the formula. So over here, let's grab our T matrix. So our transition matrix, let's define it. Let's go menu 1-1. Menu 1-1. Define T equals, and we want to get a matrix up, 2 by 2, 2 by 2. Okay, so we've got 0.4, 0.7, 0.6, 0.3. 0.4, 0.7, 0.6, 0.3. Done. We've defined T. Now let's define S naught. Menu 1-1. Oh, we'll do it a different way. I'll show you another way to define things. Go S0. You can actually go control and this funny equals thing here with the colon, that means define. So that's another way you can define. Let's grab our matrix here, 0, 1. And you'll see it'll do the same thing. It'll define it. So whenever I type in S0, yeah, we get the 0, 1 there. Okay, let's find S2. So in fact, I can go S2 control is defined as t squared times S0. There we are, and it gives us our answer. Beautiful. So that colon equals is actually really useful for defining variables. There, that's quite a useful one instead of menu 1 to define. And if you want to be even more precise, I mean, you can put caps on, so you could even make the T capital when you define it. So you can see there, even if you make it capital, it's the same as the lowercase. Doesn't matter there. But yeah, that looks quite nice. It looks like the actual equation, which makes it easier to work with. I hope that reminded you about Markov chains, and if you have been, thanks for watching.